Okay, so here we're going to convert an equation from general form to standard form. All right, we're going to indicate the type of conic section and all the key features. All right, vertices, foci, asymptotes, directrix, whatever we might happen to have. So we look at our first equation and we notice that we're going to need to complete the square to get the idea of our conic section. So I'm going to go ahead and separate my x's and my y's. Okay, and 16x. Now I'm going to go ahead and factor for simplifying to create what I will use to get a perfect square. So if I am factoring, all right, I'm going to be now at that step. Okay. Now, so to create a perfect square, for the x's, I'm going to take half of -4, which is -2, and I'm going to have that squared. But in order to do that, I had to understand that really I was adding 4, and if I do it to one side of the equation, I do it to the other side of the equation, so that what I have is x minus 2 squared. But really, it was 4 times 4, so I need to make sure that I actually add 4 times 4. Right? Now, for my y, I have plus 9, right? I take half of 2y, or I take half of the coefficient of 2y, which half of 2 is 1. So I'm going to have y plus 1 squared. But really what I was doing was I was saying, hey, really I added 1 to make a perfect square. And if I add to one side, I have to add to the other side. But really it was 1 times 9. Right? So I need to make sure I add 1 times 9 to both sides. Right? So then I have 11 plus 16 plus 9. And if I do 11 plus 16 plus 9, that's going to give me 36. Right? And note that 4 times 9 is 36. So if I'm going to get to standard form, I need to divide every term. By 36. All right, so I'm going to divide everything by 36, and that's going to get me to my standard form, which is going to be x minus 2 quantity squared all over 9 plus y plus 1 quantity squared all over 4 equals 1. So there's my standard form. Now, realize and recognize that if I don't have this equal to 1, then I'm going to have fractional pieces, which will still work. All right. Now, next part, we need to identify our vertices, our foci, our center, all of those pieces. So we should be able to identify that for this case, our center is the point 2, -1. All right. I should also be able to identify that A is going to be the larger number, so the square root of 9, which is 3. B is going to be the smaller number, the square root of 4, which will be 2. And I know that for ellipses, the relationship is b squared equals a squared minus c squared, which means that 4 is equal to 9 minus c squared. So that would mean c is equal to the square root of 5, because 9 minus 4 is equal to 5, and c squared is 5. How does that help me? Well, I know that the distance, right? I know that the distance from my center to my major axis vertices are, in this case, going to be a line from the x. So I'm going to go 3 units to the left of 2. All right, and I'll have the point -1, -1. And I'm going to go 3 units to the right of 2. So that's going to be 5, -1. And this would be along my major axis. Right? Now, along my minor axis, I have vertices as well. Right? And along my minor axis, I notice that the b value is 2. Right? So and that's underneath the y. So my minor axis is going to be, right, for one vertex, same x value as my center, but 2 units above my y. So that would be to +1. Right? And for the other vertex, same x value as my center, but 2 units below -1, which will be -3. Right? And those are my vertices on what we call the minor axis. Okay. Now I know I also have foci, right? And for my foci, if I need to look at this graphically, I can get the idea graphically. For the foci, I need to be able to identify, right, where I'm going to lie. So I'm going to have my center, and I know I'm going to be stretched a little bit vertically, but I'm going to be stretched more horizontally, and my foci will be right between my vertices and my center along my major axis, and my major axis happens to be horizontal here. So my foci is going to be √5 units to the left and √5 units to the right, because my ellipse is stretched more horizontally because x has the larger denominator. So for my foci, I have, right, √5 units to the left, and I have √5 units to the right. And those are my foci. So I have all the information clearly identified. I'm not asked to graph here, but graphing it can certainly help me visualize. So once again, right, let's indicate what we know. So the distance from the center to the focus is c. The distance from the center to the minor axis is b, or the minor axis vertex, and the distance from the center to the major axis vertex is a. And we do have that relationship. That b squared is equal to a squared minus c squared. Okay, so that's the information that we have there. Okay, so next, all right, our next little piece that we will work with is our equation down here. Okay, so notice for this equation, we do not have y squared. So that means we're going to have a parabola, right? So I'm going to go ahead and keep my x's on one side of my equation. I'm going to say that's going to be a 4, right? Factor out, that'll be x squared plus 4x, right? And I'm going to move everything else to the other side. So that's going to be 3y minus 19. So I'm just reorganizing. Completing the square, half of the 4x is 2. So that's going to be x plus 2 quantity squared, right? But this would be really plus 4, and really and truly it's 4 times 4. So this would be over here plus 16, all right? So now I have 4 times x plus 2 squared is equal to 3y minus 3. Now, note that our general form for a parabola, that we spoke about earlier, is that y minus k squared equals 4p times x minus h, or in this case, x is squared, so we're just going to switch the x squares and the y not squared. So our general form, if we recall, is going to be that idea that I'll have x minus h quantity squared is equal to, right, 4p times y minus k. So that's the form I'm trying to get to. So the first thing that I'll do is to keep the 4 on the left side for right now, and I'll have x plus 2 squared. And I'll factor out a 3. So that's going to be 3 times y minus 3. Okay. And then I'm going to divide both sides by 4. So I have x plus 2 squared is equal to 3/4 times y minus 3. And that's my standard form. That's my standard form for the parabola. Okay. So for our parabola, we can identify our vertex. All right. And for the parabola, the vertex will be at -2, +3. For our parabola, we can also identify our focus and we can also identify our directrix, right? Those are the key features when I'm working with the parabola, right? So I'm just going to go ahead and plot. We'll say that there's my vertex. There's my vertex. And I have an x squared and I have positive, right? I've got positive coefficient to the y. So I know that my parabola is actually going to open upwards because I have the x squared and I have that positive coefficient to the y. Right? So say, hey, there's my parabola, which means I have a focus that's going to be above and I have a directrix that's going to be below. But I need to figure out how much above, how much below. Well, I know that 4p is what I'm using, right? So 4p needs to be 3/4, which means that p is going to be equal to 3/16, right? So really a very, very small value for p. That's okay, right? It's all right if I have a very small value, right? But I know that that p is going to be the distance from my vertex to my focus, right? So for my focus, x value -2, and the y value is going to be 3/16 above 3. So I'll just say 3 plus 3/16. Okay. And my directrix is going to be y equals, because it's a horizontal line, and it's going to be 3/16 below my vertex. So that's going to be 3 minus 3/16. Okay. And if I wanted to simplify that, I know that 16 times 3 is equal to 48. So I could say that my focus is really at -2, right? And then I would have 48 over 16 plus 3 over 16, which would be then 51 over 16. And for my directrix would be 48 over 16 minus 3 over 16. So that would give me y equals 45 over 16. And there I have my information for my parabola, right? The graph can make it easier to look, of course. And I have my information for my ellipse.